Mars, our seemingly barren neighbor, holds secrets that challenge our very understanding of planetary formation and cosmic history. Its unusual features, like a highly elliptical orbit and a stark geological divide, hint at a past far more dramatic than we once imagined. Could these anomalies be echoes of a lost world? Or are they simply natural consequences of our solar system's chaotic dance? Beyond its iconic red hue, Mars presents a series of profound scientific puzzles that defy simple explanation. From its strangely elongated orbit to the dramatic two-phase dichotomy of its surface, the red planet seems to whisper tales of cataclysmic events. These anomalies force us to question the very processes that shaped our solar system, pushing the boundaries of conventional planetary science. You might think planetary orbits are perfectly circular, but Mars's path around the Sun is surprisingly elliptical, far more so than Earth's. This extreme eccentricity causes its distance from the Sun to vary wildly, leading to significant climatic shifts throughout its year. It's a dynamic dance influenced by unseen gravitational tugs, constantly reshaping the planet's destiny. Mars's eccentric orbit is not a random anomaly, but a direct consequence of the intricate gravitational dance within our solar system. Over billions of years, the immense gravitational pull of gas giants, particularly Jupiter, has subtly perturbed Mars's path, stretching it into its current elongated shape. This ongoing celestial ballet ensures that no planet's journey is ever truly isolated. The significant orbital variations of Mars, driven by its eccentricity, have profound climatic consequences for the planet. When Mars is closer to the Sun, it experiences warmer temperatures and increased atmospheric pressure, potentially allowing for more liquid water. Conversely, its distant aphelion brings colder, harsher conditions, highlighting how orbital mechanics dictate a planet's habitability. Look closely at Mars, and you'll see a planet starkly divided, a heavily cratered, ancient southern highland contrasting sharply with a smooth, younger northern lowland, a phenomenon known as the Martian Dichotomy. This dramatic geological split suggests a single, cataclysmic event in its early history. It's as if two different worlds were stitched together, creating a planetary puzzle. The prevailing scientific theory for Mars's dichotomy is a colossal giant impact event that reshaped the planet early in its formation. Evidence points to a massive object, perhaps Pluto-sized, striking the northern hemisphere, excavating the vast Borealis basin and thinning the crust. This single, violent collision explains the stark geological differences observed across the planet's surface. The northern basin of Mars is characterized by its smooth, low-lying plains and a significantly thinner crust, indicative of a younger geological age. In stark contrast, the southern highlands are heavily cratered, elevated, and possess a much thicker crust, reflecting an ancient, primordial surface. This profound crustal difference is a key piece of evidence supporting the giant impact hypothesis. Imagine Mars with a thick atmosphere and flowing rivers. Scientific evidence overwhelmingly suggests this was once its reality. But where did it all go? The red planet suffered a catastrophic atmospheric loss, transforming it from a potentially habitable world into the cold, arid desert we see today. This dramatic change was not sudden, but a slow, relentless stripping away over billions of years. The crucial turning point for Mars's atmosphere was the demise of its global magnetic field approximately 4 billion years ago. Without this protective magnetosphere, the planet became vulnerable to the relentless onslaught of the solar wind. This loss of its internal shield directly led to the gradual atmospheric stripping, leaving Mars exposed and barren. The solar wind, a continuous stream of charged particles emanating from the sun, acts like a cosmic sandblaster, slowly eroding a planet's atmosphere over vast stretches of time. These energetic particles collide with atmospheric gases, imparting enough energy to allow them to escape into space. Without a strong magnetic field to deflect it, the solar wind relentlessly strips away lighter atmospheric components, molecule by molecule. The NASA MAVEN spacecraft has provided crucial direct observations confirming the ongoing process of atmospheric escape on Mars. By studying the upper atmosphere, MAVEN has measured the rate at which gases are being stripped away by the solar wind, particularly during solar storms. These insights solidify the scientific understanding of how Mars lost its once dense atmosphere, offering a chilling glimpse into planetary evolution. Mars is home to some truly colossal geological megastructures, like the towering Olympus Mons and the sprawling Valles Marineris, alongside its two peculiar, tiny moons, Phobos and Deimos. These features, seemingly out of place on such a small planet, hint at powerful internal forces and dramatic external events. Understanding their formation unlocks deeper secrets about the red planet's tumultuous past. The immense Tharsis region and the colossal Olympus Mons on Mars are products of sustained hotspot volcanism, driven by a stationary mantle plume beneath the crust. Unlike Earth, Mars lacks plate tectonics, allowing volcanic activity to concentrate in one spot for eons. This continuous outpouring of lava built up these gargantuan structures, creating the largest volcanoes in our solar system. The monumental Valles Marineris, a canyon system stretching thousands of kilometers across Mars, was not carved by water erosion, but by powerful tectonic forces. It is a vast rift system formed as the Martian crust stretched and fractured under the immense stresses exerted by the uplift of the nearby Tharsis region. This geological scar reveals the planet's internal dynamics on a grand scale. Mars's two tiny, irregularly shaped moons, Phobos and Deimos, are not typical planetary satellites, leading to much debate about their origin. The leading theories suggest they are not captured asteroids, but rather remnants of a massive impact on Mars itself. Debris from such a collision would have formed a ring around the planet, eventually coalescing into these peculiar celestial bodies. Prepare for a radical idea. The exploded planet hypothesis proposes that the asteroid belt isn't just leftover debris, but the shattered remnants of a once thriving planet. This controversial theory, championed by astronomer Tom Van Flandern, attempts to explain several solar system anomalies that conventional models struggle with. It paints a dramatic picture of cosmic destruction, challenging our understanding of planetary evolution. Tom Van Flandern argued that the standard accretion theory of planet formation had critical flaws, such as the meter barrier problem. He proposed that planets were ejected from the sun via solar fission, and that the Titius-Bode law hinted at a missing planet in the asteroid belt. Crucially, he believed Mars was once a moon of this destroyed world, Maldek, explaining its unusual characteristics. Van Flandern challenged the standard model of planetary accretion, highlighting issues like the meter barrier problem, where meter-sized objects should spiral into the sun rather than growing into planets. He also questioned how high collision velocities in the early solar system would allow for gradual accumulation. These critiques, while not overturning the model, spurred further research and refinements in our understanding of planet formation. In a truly unconventional twist, Van Flandern proposed the solar fission theory, suggesting that planets were not formed from dust and gas, but were instead directly ejected from a rapidly rotating young sundae. He envisioned massive blobs of plasma being flung outwards, which then cooled and condensed into the planets we see today. This radical idea aimed to explain the flat ecliptic plane and the angular momentum of the solar system. The Titius-Bode law, an empirical rule describing planetary distances, famously predicted a missing planet at 2.8 astronomical units, precisely where the asteroid belt resides. This numerical gap fueled speculation for centuries about a destroyed world, leading to the naming of a hypothetical planet, Phaeton. While now considered a numerical coincidence, it historically provided a compelling slot for a lost world. Van Flandern theorized that Mars's small size, highly eccentric orbit, and the dramatic Martian dichotomy were not original planetary features, but rather scars from its past as a moon. He proposed that Mars was once a satellite of a much larger planet, Maldek, which subsequently exploded. This catastrophic event, he argued, flung Mars into its current orbit and left it with its distinctive geological scars. Despite its dramatic appeal, mainstream science largely rejects the exploded planet hypothesis due to overwhelming evidence contradicting its core tenets. The theory struggles to account for the observed mass and composition of the asteroid belt, and more robust scientific explanations have emerged for the anomalies it attempts to address. While intriguing, it simply doesn't align with our current understanding of astrophysics. A major hurdle for the exploded planet hypothesis is the critical mass problem of the asteroid belt. The total mass of all asteroids combined is only about 4% of the Moon's mass, far too little to be the remnants of a full-size planet. Furthermore, the diverse chemical compositions of asteroids suggest they never coalesced into a single, molten body, undermining the idea of a shattered world. The meter barrier problem, which questioned how meter-sized objects in a protoplanetary disk could grow without spiraling into the star, was a genuine puzzle for early accretion models. This issue was elegantly resolved by the concept of streaming instability. This mechanism explains how dust and pebbles can rapidly clump together into kilometer-sized planetesimals, effectively bypassing the problematic meter scale. The discovery of hot Jupiters, gas giants orbiting incredibly close to their stars, initially challenged traditional planet formation theories. This phenomenon is now explained by planetary migration, where planets form in the colder outer regions of a protoplanetary disk and then gradually move inwards due to gravitational interactions with the disk or other planets. This dynamic process reshapes entire planetary systems. The remarkably flat ecliptic plane of our solar system, where all planets orbit in roughly the same plane, is elegantly explained by the formation from a single, rotating protoplanetary disk. As this disk of gas and dust collapsed under gravity, its rotation naturally flattened it into a pancake-like structure. Planets then formed within this flattened disk, inheriting its planar alignment and common orbital direction. While historically significant, the Titius-Bode law is now largely considered a numerical coincidence rather than a fundamental physical law. It fails to accurately predict the orbit of Neptune and does not universally apply to exoplanetary systems. Modern science attributes its apparent success in our solar system to orbital resonances and the natural spacing that arises during planetary formation, rather than a deeper, predictive power. Prepare for a truly shocking idea. The Mars atomic war theory, proposed by plasma physicist John Brandenburg, posits that the red planet's current state is the result of an ancient, interplanetary nuclear conflict. This controversial hypothesis suggests that advanced Martian civilizations were annihilated by atomic weapons, leaving behind telltale radioactive signatures. It's a chilling thought that challenges our understanding of cosmic history. John Brandenburg cited several anomalies as his proof of an ancient Martian nuclear war, including an excess of xenon 129 in the Martian atmosphere. He also pointed to anomalous ratios of other isotopes, suggesting massive neutron radiation, and identified two hotspots on Mars as alleged hydrogen bomb detonation sites. Furthermore, he interpreted thin layers of radioactive elements as global fallout from these cataclysmic events. The presence of elevated xenon 129 in the Martian atmosphere is a key piece of Brandenburg's argument, as this isotope is primarily produced by nuclear fission on Earth. He interpreted this as a direct signature of ancient nuclear explosions on Mars. However, mainstream science offers natural explanations for this anomaly, such as cosmic spallation and volcanic outgassing, which are far more plausible. Brandenburg interpreted the elevated concentrations of thorium and potassium on the Martian surface as evidence of global radioactive fallout from ancient nuclear weapons. He suggested these elements were spread across the planet as a result of massive explosions. However, these elements are naturally occurring in planetary crusts, and their distribution on Mars correlates with geological features, not artificial dispersal. In a truly speculative leap, Brandenburg proposed that Mars's iconic red color was not due to natural oxidation, but rather the result of the thermal effects of atmospheric nuclear explosions. He theorized that these blasts shock oxidized and vitrified the Martian soil, giving it its characteristic hue. This explanation stands in stark contrast to the well-understood geological process of iron oxidation. Despite its sensational claims, the Mars atomic war hypothesis is widely dismissed by the scientific community due to a lack of compelling evidence and more plausible natural explanations. The proof cited by Brandenburg can be readily accounted for by known astrophysical and geological processes. While intriguing, the theory simply doesn't hold up to rigorous scientific scrutiny. The excess xenon 129 on Mars, often cited as evidence for nuclear events, is naturally explained by cosmic spallation and neutron capture. Mars's thin atmosphere and lack of a global magnetic field expose its surface to high-energy galactic cosmic rays, GCR. These rays shatter atomic nuclei in the Martian soil, producing neutrons that then convert other isotopes into xenon 129, a well-understood natural process. The presence of thorium and potassium on Mars, which Brandenburg interpreted as nuclear fallout, has straightforward natural explanations. These are common radioactive elements found in planetary crusts, and their distribution on Mars is consistent with geological processes like volcanism and crustal differentiation. There is no scientific evidence to suggest an artificial origin for these elements. The iconic red hue of Mars, which has captivated humanity for millennia, has a very simple and natural scientific explanation: iron oxidation. Over billions of years, iron-rich minerals on the Martian surface have slowly rusted due to exposure to oxygen, forming iron oxides. This ubiquitous process, similar to rust on Earth, is responsible for the planet's distinctive color. Beyond scientific hypotheses, a fascinating array of esoteric narratives and channeled teachings describe a lost planet named Maldek, offering a metaphysical perspective on its destruction. These accounts, often rich in detail, weave a story of advanced civilizations and karmic consequences. They present a parallel narrative that, while unscientific, resonates with themes of hubris and cosmic justice. The RA material, channeled in the 1980s as the Law of One, provides a detailed esoteric account of Maldek's destruction. According to RA, Maldek was a third-density civilization that annihilated itself through a devastating war, driven by negative polarity and service to self. This cataclysmic event left the souls of its inhabitants trapped in a knot of fear, seeking karmic resolution on Earth. The RA material is a series of texts derived from channeling sessions, where a medium entered a trance state to purportedly receive information from a non-physical entity named RA. It is presented as a higher, metaphysical cosmology, not a scientific treatise. From a scientific perspective, channeling is considered a psychological phenomenon, and its information is not empirically verifiable. According to the RA material, the Maldekian civilization, despite its advanced technology, succumbed to a devastating internal conflict, a Maldekian war, driven by extreme negative polarity. Their focus on service to self and the misuse of powerful weapons led to the complete destruction of their planet. This self-inflicted catastrophe serves as a stark warning about the consequences of unchecked technological and spiritual imbalance. The knot of fear describes the profound spiritual trauma experienced by Maldekian souls after their planet's destruction, leaving them entangled in a collective state of terror and confusion. This knot represents their unresolved negative karma and the deep-seated emotional wounds from their self-annihilation. According to the RA material, these souls subsequently incarnated on Earth to work through their karmic lessons and find healing. In esoteric circles, the story of Maldek finds a surprising link to ancient texts and the figure of Lucifer, the morning star. Researcher George Hunt Williamson interpreted biblical passages, particularly from Isaiah, not as a literal fall of the devil, but as an allegorical description of a destroyed planet. This interpretation casts Maldek as a cosmic cautionary tale, echoing through humanity's oldest stories. George Hunt Williamson found a profound allegorical meaning in Isaiah 14, specifically the passage, "How you are fallen from heaven, O morning star, son of the dawn." He interpreted this not as the literal fall of a spiritual entity, but as a symbolic description of the destruction of a celestial body, which he linked to the lost planet Maldek. This reinterpretation transforms a religious text into a cosmic narrative of planetary demise. The Maldek story, whether scientific or esoteric, serves as a powerful and timeless warning against technological hubris. It illustrates the catastrophic consequences when advanced technology is wielded without corresponding spiritual wisdom, empathy, or moral responsibility. The narrative emphasizes that the pursuit of power and service to self can lead to self-destruction on a planetary scale, a crucial lesson for humanity. Intriguingly, certain cultural parallels and historical anecdotes hint at what some consider insider information regarding the Maldek narrative. These include the surprising prescience of comic book creators and the accounts of remote viewers. While not scientific proof, these coincidences fuel speculation about hidden knowledge or collective unconscious archetypes related to a lost world. Decades before the Viking probes, comic book legend Jack Kirby published a story in 1958 featuring astronauts discovering a giant stone face on Mars, a planet that was once a moon of a larger world destroyed by war. This uncanny resemblance to later scientific and esoteric narratives, coupled with Kirby's alleged contacts with rocket scientists, has led some to speculate about his access to insider information. It's a fascinating intersection of fiction and potential foresight. During the declassified U.S. military program Project Stargate, renowned remote viewer Joe McMoneagle reportedly described seeing a civilization of giants on a dying Mars during a session focused on specific Martian coordinates. While remote viewing is a controversial parapsychological ability, this account adds another layer to the persistent narrative of a once thriving, now lost Martian past. It's a glimpse into the fringes of human perception. Our understanding of Mars and planetary evolution is constantly being refined by current missions, which provide unprecedented future insights into the red planet's past and potential for life. Rovers like Curiosity and Perseverance are meticulously exploring its surface, while asteroid missions are unraveling the secrets of the early solar system. These ongoing explorations continue to challenge and expand our scientific models. The tireless work of Mars rovers like Curiosity and Perseverance is unequivocally confirming the planet's ancient watery past, revealing evidence of lakes, rivers, and deltas. Furthermore, these rovers have made groundbreaking discoveries of complex organic molecules, fueling speculation about past life on Mars. These findings are transforming our understanding of Martian habitability and the potential for extraterrestrial biology. Dedicated asteroid missions, such as Dawn and OSIRIS-RX, are providing invaluable insights into the early solar system by studying these primordial remnants. By analyzing their composition and structure, scientists can piece together the conditions and materials present during planet formation. These studies help us understand the building blocks of our solar system and the processes that shaped its evolution. The breathtaking pace of exoplanet discoveries is profoundly challenging in refining our planetary formation models, forcing us to reconsider what constitutes a normal solar system. The existence of hot Jupiters and other unexpected configurations demonstrates the incredible diversity of planetary systems. These findings push the boundaries of our understanding, revealing the complex and dynamic processes that govern planet formation across the cosmos. Regardless of its scientific veracity, the Maldek narrative offers a profound and universal warning to humanity, echoing through both scientific and esoteric accounts. It serves as a powerful allegory for the dangers of unchecked technological advancement divorced from spiritual wisdom and ethical responsibility. This ancient tale implores us to choose a different path, one of unity and conscious evolution, to avoid a similar fate. What's truly astonishing is the scientific convergence of seemingly disparate fields of astronomy, physics, geology, and even metaphysics, all hinting at a profound cosmic tragedy in our solar system's past. While their interpretations differ, The recurring themes of planetary destruction and cataclysmic events suggest a deeper, underlying truth. This unexpected alignment of evidence from various disciplines paints a compelling, albeit unsettling, picture. The Maldek story underscores a critical wisdom imperative. Technological progress must be meticulously balanced with spiritual wisdom and ethical development. Without a foundation of empathy, responsibility, and a focus on service to others, advanced capabilities can become tools of self-destruction. This balance is not merely philosophical, but essential for the long-term survival and flourishing of any civilization. The tragic fate of Maldek serves as a stark reminder, urging humanity to avoid the perilous path of division, unchecked ego, and the misuse of power. It warns against prioritizing service to self over collective well-being and against allowing technological prowess to outstrip moral and spiritual growth. This ancient cosmic tale is a powerful call for conscious evolution and a harmonious future.